Welcome to today's lesson on the production of potable water in areas of drought, an essential process in enabling access to water. In our lesson today, we will start by covering the key stages of the water cycle, including evaporation, precipitation, condensation, and collection. We will then learn why producing potable water is crucial in drought-stricken areas. We will then delve into the specific methods used to make water safe for consumption, with a particular focus on the process of desalination. So far, you have learned about the basic principles of ecology and the significant impact of environmental changes, including variations in water availability. This foundational knowledge will help us understand the urgency and necessity of creating potable water in areas suffering from drought. Understanding the production of potable water and the role of desalination advances our biological understanding by showing us how science and technology can address critical environmental challenges. It highlights the interplay between ecosystems and human ingenuity in ensuring our survival and maintaining ecological balance. Let's get started. Before we dive into desalination, let's quickly recap the water cycle. The cycle involves 4 key stages. 1. Evaporation. The sun's energy heats up water from oceans, rivers, lakes, and plants, turning it into water vapor. This process includes transpiration, where plants release water vapor into the air. 2. Condensation. As the warm air carrying water vapor rises and cools at higher altitudes, the vapor condenses to form clouds. 3. Precipitation. Water falls from the clouds as rain, snow, or sleet, supplying fresh water to ecosystems on land. 4. Collection. The water eventually drains back into oceans, rivers, and lakes. This results in the water once again evaporating, therefore restarting the cycle. This cycle is essential for the distribution of fresh water globally. The water cycle is crucial for providing fresh water for drinking, agriculture, and sustaining life. However, in some areas, drought disrupts this cycle, making fresh water scarce. Droughts can severely limit access to potable water, presenting a significant challenge for communities that depend on consistent water supply. When the usual sources of fresh water like rivers, lakes, and underground aquifers dry up, alternative methods are needed to provide safe drinking water. One effective solution is desalination. Desalination is the process of removing excess salts and other minerals from seawater to produce potable, drinkable water. There are 2 primary methods of desalination. First, let's discuss distillation. In distillation, seawater is heated until it boils, turning into steam and leaving salts and other impurities behind. The steam is then cooled and condensed back into liquid water, which is now purified and free of salts. This method mimics the natural water cycle's evaporation and condensation stages, but accelerates the process using technology. Distillation can have drawbacks. Distillation can be energy intensive, requiring substantial heat to boil the water. The other method for desalination is reverse osmosis. Reverse osmosis involves forcing seawater through a partially permeable membrane at high pressure. The membrane allows only water molecules to pass through, blocking salts and other impurities. As a result, the output is pure water, with the salts and impurities left behind as brine. This method is more energy efficient compared to distillation and is commonly used in modern desalination plants. However, the process still requires significant energy to create the necessary pressure, and the membranes can foul, requiring maintenance. Both distillation and reverse osmosis require energy. In areas experiencing drought, the energy demand for desalination must be managed carefully. Innovations, such as solar or wind energy, can help reduce the carbon footprint of desalination plants and make the process more sustainable. Desalination doesn't just benefit areas with drinking water shortages. The purified water produced through desalination can also be used for agricultural irrigation, industrial processes, and supporting ecosystems during times of water scarcity. In today's lesson, we explored the production of potable water in drought-prone areas, focusing on desalination. We began by defining potable water as safe drinking water, crucial in regions where natural fresh water is scarce. We then covered the key stages of the water cycle, including evaporation, precipitation, condensation and collection. We examined traditional water collection methods, like rainwater harvesting and reservoirs, and discussed their limitations during extended droughts. This led us to consider desalination as a reliable alternative for producing drinkable water. Desalination removes salt and impurities from seawater with two main methods: reverse osmosis, which filters seawater through semi-permeable membranes, and distillation, which evaporates and condenses seawater to obtain fresh water. We discussed the advantages of desalination, such as a consistent water supply and the use of abundant seawater, alongside the challenges like high energy use, environmental impact, and infrastructure costs. You should now understand how desalination addresses water scarcity, its methods, and the associated benefits and challenges, providing insight into water resource management in drought-affected areas.